Okay, so if we're going to graph this one, it's the first one in your notes that I want you to try. Uh, First of all, you got to know what the parent looks like. And the parent for the square root function looks like this. Starts at 0, 0, goes to 1, 1, and then goes to 4, 2. Why would it go to 4, 2? Because it's a square root. You take 4, you take the square root of that, you'll get 2. That's why this is plus 2. Okay, so anyway, it looks kind of like that, and then you connect those dots and just keep going. That's the square root function. But that's the parent one. This one's been changed a little bit. Remember the stuff that's on the inside underneath this? It's all left, right kind of changes. Okay, so this has been changed, moved 1 to the right, and that's a left, right kind of a change. Flip that negative. Flips it. And now the order's important too. There's a lot to remember on this. The stretching and the flipping, you're right. You stretch before you flip, that's true. But on this one, we're talking about moving and flipping. And which one do you do first? Well, think of it this way. In math, you normally do parentheses first. And the point of a problem like this one is that on the inside here, you don't do the normal thing first. Remember, on the inside, everything's counterintuitive. And so if you normally do parentheses first, you don't do the parentheses first. You do the flip first. So I should flip it first. It looks kind of like this. And then I should do the other part, which is the move, which is move which way? That's that left. That's right. Okay, so go over to the right one. There we go. My right answer is the one in black. All right. That brings up another topic, which is domain and range. The domain on this black function, I'd like you to figure out, domain is the x's. Figure out what the domain of the black function is. Let me pause where you do that. Oh, and also figure out the range. Negative infinity to, because it goes from way over there all the way up until here, and then it stops. All right, and the range, finish it. This from 0 all the way up to 0 to infinity, and what do you think on the bracket versus? Yeah, raise your hand if you would have had that right. Okay, not too much worry about domain and range then. All right, this one's a little tougher because it's been moved and flipped. More and more stuff happened to it. Write me the equation for it. If they give you the graph, you write the equation. The black one, the one I circled. Give me the equation for the black one. Well, I know it's a square root function. It's got to have an x. And it looks to me like it moved 2 to the left. That's a plus 2. Looks to me like it moved down 2. This is, it's down here. So I'm going to go down 2 is minus 2. And then the only other thing it needs to flip left, right. How do I do a left, right flip? Put a negative in here. How many of you remembered to put a parenthesis? Excellent. All right. That's what you do for that one. Moving on. These are all exactly the same. The stuff on the inside is left, right. The stuff on the outside is up, down. Remember, you can't trust the stuff on the inside. That was demonstrated the other day. Even you can't trust the cats on the inside. Did you hear about the cat? They, prisoners in Mexico had trained the cat that lived kind of in the prison and then would run to the neighborhood that was outside the prison. It kind of was, cat was moving freely between the two because, they cared whether the cat was in prison or not, right? So the inmates had trained the cat to carry stuff for them. And so they found the cat like looking You know, it just looked strange to the guy, one of the prison guards. It's like, what's wrong with the cat? So he looked at the cat more closely, and it was carrying a little bag of tools, like tools you'd use to break out of prison, kind of tools, to try to chip through the concrete and stuff. So they had trained the cat to go back and forth and bring them stuff. They don't know how many times the cat had brought them stuff, but this time he got caught bringing it to the bag of tools. No, I think it was like strapped to the cat. Now, I'm thinking that the cat was like had a lot of hair, and they just kind of like had a little bag and tied it on him. I don't know. Apparently, wasn't a great. I don't know. It must have made the cat just look, like not as maybe they look the cat looked too fat or something, but it got their attention anyway. So that we used the cat for. It is tough to train cats. I mean, that's one of the things that's notable about it. You can train dogs really easily, but cats, it's not easy to train them. Can you really? You've trained your cat how to sit? Cool. So you just say sit and it sits? All right. I'm surprised if the cat hasn't trained you because cats are usually pretty good at that. They can like train you by their annoying meowing to do whatever they want. All right. Circle. The circle equation looks something like this. Do you remember how the center of the circle is this part and the radius goes there? It's all based on this. We have a circle, and it happens to be right at the center of the whole universe, where it's got 0, 0 as its center. And then its radius is like this. Let's say its radius is 1. Then you get, there's this distance would be x, because that's the way we go for x. And this distance would be y, because that's the direction we go for y. And this would be 1. And that's why it's x squared plus y squared should equal 1 squared. Or if this 1 was even different, which is the radius, it's r squared. That's where that comes from. And then if you want to move the circle to the right, and let's say up 5, x is this way, y is this way. Okay, so that's where that whole circle thing comes from. So if I have this, you should be able to tell me what's the radius? It's 5, because you take the square root of that thing. Because in other words, I could have a 5 squared right there, right? And if that's the radius is 5, then how about the center? Do we use the numbers we see or the opposite of the numbers we see? Why can't we trust y anymore? We used to be able to trust the up and down moves. They made sense, but now they can't trust them because they're on the inside. They can't. All right. So, what if I give you this one? Actually, let's do this one. Just write me the equation for that one. It's pretty simple because it hasn't even been moved left or right or up or down. It's just bigger than normal. Bigger than the parent. So how do I say it hasn't moved? Well, you just say plus 0. Yep. So the point is you could either have this plus blah blah blah, or you can just say x plus, since y hasn't moved, to be y squared equals, and then we just got to know what the radius is. What's radius? 3. So you go like that. Raise your hand if you think I'm right. Nobody's raising their. Oh, a couple people are. I'm close, but I'm not exactly right. Squared. There you go. Either one's okay. All right, moving on. Here is a circle that doesn't have a center at the normal spot. It's been moved. Would you please write me its equation? And it is, if you're following in the notes, it is one of the things you can write. So you can see it up close on your own screen. And I showed you the trailer for Transformers at the beginning here. You know the Transformers 4 is coming out next. Coming out in 2014. Not even this year, it's next year. Yes, Anchorman 2 is. What did he? Cool. That could be funny. All right, your center here's a 3, 3. Your radius, that's pretty easy. It's just count up how far it is from here to here, and that would be 7. Then the equation, that's the harder part. You got x squared plus you got your y squared, and you got your radius squared, which would be 49. I can do that. And then which way did it get moved? How do I do right 3? Is that plus 3 or minus 3? How do I do up? It's on the inside, so normally be plus 3. Get that? All right. You think that would mean down 3, but it doesn't. It's up 3. Okay. Enough about circles already. Let's move on. Circle to death. All right. So, thankfully, that pretty much covers everything that you need to know for transformation. So, now you got a whole bunch of time to work. I want to warn you, tomorrow we're going to do a bunch of grading. If you haven't graded anything in a while, we need something in that 15% category. You might have grade a couple. But yesterday's is the first day of the packet. Today's assignment is to do the next day. It'll be called day 2 in your packet. And I'd like to give you a bunch of work time on that. And I'll come out and run around and execute. All right, so that's all we got for you.